Alright, hi, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning, everyone. So, welcome back to my YouTube channel. My god, okay, bye. Ignore my weird introduction. So, okay, let's start it. Okay, last week we have learned about chapter 4.3. I have introduced you guys on what is orbital overlap, what is valence bond theory, what is hybridization, and like a lot of things actually. So today, what we're going to do is we're going to look at the tutorial questions, and I will explain to you on how to answer this question in your tutorial books. It's not like all questions will be discussed, by certain questions that caught my eyes I will discuss. Okay, all right. So in this tutorial, what we're going to do is we're going to draw and describe the formation of sigma and pi bonds from the overlapping of orbitals. And we're going to describe the formation of hybrid orbitals of a central atom. And we're going to illustrate the hybridization of the central atom and the overlapping of orbitals in the molecule. Alright, so for question 1, it's just a very direct and like very simple question. It asks us to describe the formation of sigma and pi bond. So as you know from our notes, we know that the sigma bond are formed by the n to n orbital overlapping. Dari hujung orbital ke hujung orbital. Bila dia overlap, then that's what we call sigma bond. Okay, the end-to-end orbital overlapping. So what is the pi bond form? So how is the pi bond form? So pi bonds are formed by the side-to-side overlapping of orbitals or sideways overlapping of orbitals. Okay, now let's see this question B. It asks us to explain, dia kata, use the valence bond theory to explain the bonding in HCl and show how the bond is formed by the overlapping of atomic orbitals. Okay, it asks us to explain using the valence bond theory and show. So maksudnya we have to draw and then we have to explain according to valence bond theory. So first thing first, you need to know the valence electronic configuration. So for hydrogen atom, the valence electronic configuration is 1s1. For chlorine atom is 3s2, 3p5. And if we draw the Lewis structure, it will become like this, and then it has one sigma bond here. So how to draw it? Okay, so sigma bond is formed by the end-to-end overlapping. So 1s orbital, end-to-end overlapping, hujung p orbital. So like this. Okay. Oops, cemberut je. One more time. Okay. Memang buruk. Okay, so we label here 3p, we label here 1s, and then this is h, and then this is cl orbital. So then we label the electron 1. So one electron is contributed from h and one electron is contributed from cl. So this is the sigma bond. Okay, so how are we going to explain the valence bond theory? To explain the orbital overlapping between H and Cl. So, according to valence bond theory, the sigma bond is formed by the end-to-end orbital overlapping between 1s orbital of hydrogen atom and 3p orbital of chlorine atom. So this is how you explain the formation of sigma bond using the valence bond theory. You have to explain what orbital is overlapped with what orbital to form the sigma bond. Okay? Okay, are you clear? Alright, I hope you guys are very clear on this explanation thing. Okay, so now let us move on to question number 2. So question number 2a asks you what is meant by hybridization. This also has got inside your tutorial book, your lecture notes, and also on my previous notes from the previous tutorial. Yeah. So just a brief explanation. So hybridization is the mixing of two or more atomic orbitals to generate new sets of orbitals. So for example, we got one s orbital mixing with one p orbital. When it mixes, it will form two sp hybridized orbitals. So that is what is meant by hybridization. So now let us see question 2b. It asks us to name the hybridization of the carbon atoms in the following molecules. So we have to give what is the hybridization state for all the carbon atoms in the molecule. So for question number B, 1. CH3, CH double bond, CH2. So how do we do this? First, draw the Lewis structure lah. So for this carbon, first step you have to draw the carbon-carbon multiple central atom kan. So dia ni adalah multiple central atom lah. We call this. Okay. So C, C, C. This is first C, second C and third C. So look at first C got 3H around it. So 1, 2, 3. And the second C got just 1H. And the third C got 2H. Okay, and then got one double bond here between this and this. So now let's check. Semua ada 4 ke? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All of the carbon has 4 bonds. Okay, now we want to check how many electron groups around the central atom. So for C1, the total number of electron groups around the central atom C1 is 4. So 4 is in shape tetrahedral. So the hybridization state is sp3. Okay, let's look at the second carbon. So we treat the double bond as one electron group. So 1, 2, 3. So trigonal planar. So this is sp2. And 1, 2, 3. This is as well sp2. Okay, now let's look at question number B2. CH3, CO, CH3. Okay, so C, 3H. So 1, 2, 3. 1 oxygen, 1. 3H, 1, 2, 3. So this central atom C still not enough for bond, right? So we put this double bond here. Okay, so C 1, 2, 3, 4. If you calculate it like really like according to the steps, then you will find all of this is already in octet. Follow the octet rule lah. So this one also, and the formal charge also. This is the stable one lah. Alright, so now we see for each of the carbon, let's look at how many electron groups around them. 1, 2, 3, 4. So this is also sp3 tetrahedral. 1, 2, 3. So this is also sp2. This is 1, 4. So this is sp3. Okay, now let's look at the final one. Okay, number 3. CH3CN. So C. First C got 3H. CH3 and then N. Triple bond N. 1, 2, 3, 4. 1, 2, 3, 4. So this is 4 electron groups around the carbon 1. So it is sp3. And this carbon has only 2 electron groups around. So this is sp. So you have name all the hybridization for all the carbons in the following molecule. Okay. Excuse me. Alright, so next. Question number 3, it asks you to determine the hybridization of the underlined atoms. Oh, sorry, I forgot to underline the atoms here. So the underlined atoms here is aluminium, silicon, and sulfur. So first that you need to draw lah the Lewis structure. So Al will be like this, Ali3. SiCl4, and then SF4. Okay, now this one you have to draw this carefully lah. Okay, calculate all the what we call this valence electrons more so that you don't make any mistake. Okay, this but I just want to be short and simple video. So now look at around the central atom. How many electron groups around the central atom? 1, 2, 3. So trigonal planar. So the hybridization is sp2. Okay, silicon 1, 2, 3, 4. 4 is sp3. 1, 2, 3, 4, 5 electron groups around sulfur. So the hybridization is sp3d. Alright. Okay. Now. Okay, this is just a very like a basic one lah. Okay. To know what is the hybridization for the central atom, you need to know how many electron groups around the central atom. Then you can come up with the shape, and then you can come up with what is the possible hybridization for the central atom. And you can explain everything else then. Alright? So next. Look at question 4. Question 4 asks you to show the hybridization process and determine the geometry of the following species. So they gave you 3 examples. So what I'm going to discuss today is example B, SEF4. Okay, because the example A and C is very like quite a very simple one. So I want to discuss on example B. Okay. So let's look at example B. So the molecule is SEF4. So the Lewis structure for SEF4 is SE F and got one lone pair here. Okay, SEF4. This one you can calculate lah. SE how many, F how many, and then you can come up with this Lewis structure. So if you look at this Lewis structure, how many electron groups are there for bonding pair? 1, 2, 3, 4. So 4 bonding pair, and then lone pair 1. So 1 lone pair. So the electron group arrangement we calculate all. So total 5. So electron group arrangement should be trigonal by pyramidal. However, the molecular geometry only see the bonding pairs. So this is the seesaw shape. Okay. Okay, that's for SE. So now we want to look for the central atom only. So around central atom, so for central atom SE, the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4p4. 3d10. Look for 3d10. Okay, so the valence electronic configuration, we take these two lah, right? So 4s2, 4p4, that is the valence electronic configuration for SE. Because we want to focus on central atom only. So at ground state, at ground state, we draw this SE for S for P. So for S2, 1, 2, for P4, 1, 2, 3, 4. Okay. So if you look at the Lewis structure, how many bonds are there? 1, 2, 3, 4. There are 4 sigma bonds. So you need to have 4 unpaired electrons to form a covalent sigma bond. So how? Okay. We just have to, right? Okay, so we need to expand. So we need to expand it to the 4D one because we want to promote this one electron from 4p to the d orbital or 4d orbital. Because if we see the shape of the molecular geometry is seesaw, it has five electron group around the central atom. So the possible hybridization is sp3d. sp3d, the possible one, sp3d. So ada d. So we need to expand our orbital. So Se will be S for S for P. So this for S just leave it there because there is one lone pair, right, around central atom. So that will be represent the lone pair after this. So this for P, one of the electron from 4p will excite to 4d orbital. So 1, 2, 3, 4. Okay, so at hybridization state, we want to form sp3d. So sp3d, we need 1 s orbital plus 3p orbital plus 1d orbital mixed together to form 5 sp3d orbital. So the sp3d orbital is Se. One, two, three, four, 5. 1, 2, 3, 4. So this is sp3d hybridized. This is empty for the orbitals. Okay, so we have so we know that this 1, 2, 3, 4, 5, this 5 is the sp3d hybridized orbital. So now we can look at this. We can form 4 covalent sigma bond, and then we have 1 lone pair on the Se central atom. So this is empty one lah. Okay, so we need to draw now. So this sp3d hybridized orbital, it has the seesaw shape and the electron group arrangement is the trigonal bipyramidal. So we draw it based on the electronic group arrangement here. So the shape is quite like this. Okay. One. Okay, so this we need to label it Se. Okay, and then we need to label this sp3d, 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 sp3d. Okay, one more. sp3d. So this is the sp3d hybridized orbital for Se central atom. It has the shape of the trigonal bipyramidal. Okay, now they got 1 lone pair, right? So 1 lone pair, we need to put it here. So this is 1 lone pair for this one. we look at the Lewis structure here, one lone pair, right? So we draw it like this here. Okay, and then we got and then we see that the S8 central atom will be form a sigma bond with F orbital. So F got 2p orbital, right? 2p valence electron yang ada satu kosong tu kan, yang ada satu unpacked electron. So if we look at this, F, the what we call it, orbital diagram, valence electron orbital diagram will be like this. Got one unpacked electron here, right? So it can form a sigma bond with Se. So two p orbital. So this each of the sp3d will form a sigma bond with 2pf orbital. Okay. Oh my god, the drawing is so hard. Okay, next we need to label. So this is 2p, 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 and then this F. Okay, now we need to draw the electron inside the sigma bond. So this is 1, 2, oops. 1, 2, 1, 2, 1, 2. Okay, so we need to label the sigma bond here. Sigma, sigma, sigma. Anything else we forgot? No, semua dah label. So now we need to explain. Okay, so for this part of explain, we need to explain how does the sigma bond form and what is the molecular geometry according to Vesper and the bond angle. Okay. So if we want to explain, so the first explanation is to explain the formation of sigma bond. So the the SEF sigma bonds are formed by the end-to-end overlapping of two p between Allahu Akbar, between 2p orbitals of F atoms and sp3d hybridized orbitals of Se atom. So this is how you explain the sigma bond. Okay, the SEF sigma bonds are formed by the end-to-end overlapping between 2p orbitals of F atom and sp3d hybridized orbitals of Se atom. So now we want to explain the molecular geometry, excuse me. So number 2, according to Vesper theory, the molecular geometry is seesaw with bond angle of less than 90 degree, less than 120. So this is how you answer this question. So remember that for the explanation part, you have two things you need to do. Three things. You need to explain. The first, you need to explain the formation of sigma bond or the pi bond. Kalau ada dua-dua awak kena jawab. Explain. Second, you have to explain the molecular geometry and the bond angle of the molecule. So according to Vesper theory, the molecular geometry is seesaw and the bond angle with the bond angle of less than 90 degree, less than 120 degree. So this is what you get for this question. So this is how you answer this question. Okay. So make sure you have all these points. Okay. Okay, so untuk arrow, for arrow, I think this time the matrix has accept whether you want to use double-headed arrow like this for one electron, or you can draw it like half-headed arrow like this. Any of it can. Okay, it is acceptable. Okay. Now, let's look at question 5. Okay, it asks us to describe the hybridization process and determine the geometry of the following species. Okay, the question A and B, I think I have explained to you last week during the example to show how to lukis-lukis kan. So today I'm going to show you the question C and D, since in this question the central atom has charge, has negative charge and a positive charge. So how? Okay, now let's answer the first question C. So we know that the molecule is ICl2 minus. Okay, and if you draw this according to the Lewis structure, if you draw this, you will get it like this. Okay, so this is how you draw this, and then like this, got the negatively charged. Step on how to draw the Lewis structure. You need to look at the previous chapter 4.1, I think. Okay, so this is how you draw it. Okay, don't forget the negative charge here. So this is what you got, and then it got the bond angle of 180 degree here. Okay, so if you look at the electron group around the central atom I, how many bonding pair? 1, 2. So 2 bonding pair and 3 lone pairs. The electron group arrangement is supposed to be trigonal by pyramidal, and the molecular geometry is linear. So for central atom, okay, this one ada you have to do two electronic configuration so that you tak confused. Okay, if we do the electronic configuration for I atom, okay, I atom, the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4p6, 3d10, 3d10. 4s2, 3d10, 4p6, 5s2, 5p6. Okay, so banyak kau 5p5 iodine kan. Okay, 5p5. Okay, 5s2, 5p5. So this is the electronic configuration for the I. Okay, it's too panjang here. Okay, so we know that here, okay, sorry, I'm going to delete this. So here, we already know the electronic configuration for I. So we want this only 5s2 and 5p5 as the valence electronic configuration. So for the valence electronic configuration for I, it's 5s2, 5p5. However, for the valence electronic configuration for I minus, but we got the negatively charged here, right? So the negatively charged is automatic on the central atom punya. So I minus its electric configuration is 5s2, 5p6 plus 1 electron dekat outermost shell, outermost orbital. Okay, so we got our valence electric configuration. Now, if we see around the central atom, it has 5 electron group. So 5 electron groups is equal to the sp3d hybridization. Okay. So at ground state, I minus is 5s2, 5p6. 1, 2, 1, 2, 4, 5, 6. Okay, at excited state, 1 electron will be excited into the empty 5d orbital because if we look at the Lewis structure, we need 2 unpaired electrons to form a covalent bond with chlorine atom. So we need unpaired electrons, so we need to excite 1 electron from 5p into the empty 5d orbital. Okay, so at excited state, I minus is 5s. 1, 2, 3, 4, 5s, 5p, 5. So it will form 1, 2, 3, 4, 5, 6. So 1 from here will excite to here. So 1, 2. Okay, so at hybridization state, since this is the sp3d, it needs 5 orbital, it will generate 5 sp3d hybridized orbital. So here, 1, 2, 3, 4, 5. So this is the sp3d hybridized. So here we can draw sp3d hybrid orbitals. 1, 2, 3, 4, 5. One, two, three, four. So this is the sp3d hybridized orbitals. This is the empty 5d orbitals. So if we want to draw, this is like how we draw. 1, 2, 3, 4. Draw it back here. 5, 6, 7, 8. Okay, if we look at the Lewis structure, check. Oops. Okay, check whether betul tak ada 3 lone pair, 2 unpaired electron to form sigma bond. Yes, 1, 2, 3 lone pair, 1, 2 unpaired to form sigma bond. So yes, now we can draw the orbital overlapping. Okay. Oh my god. Okay, to draw the orbital overlapping, so according to the molecular geometry, its shape is linear. So dia sp3d, tapi dia kita lukis dia ikut electron group arrangement dia, trigonal bipyramidal, tapi dia shape linear. Okay, faham ke? Alright, so dia punya shape is trigonal bipyramidal. Oops. One, 2, 3, 4, 5. So this is I. So label this sp3d, sp3d, sp3d. sp3d, sp3d. Okay, and then you draw the apa tu, Cl 3p. Ada dua, right, Cl? So yang linear dia here. One, two. Okay. So this is Cl. And then we label this 3p. And then you know that they have 3 lone pairs. So 3 lone pair is here. Okay, 1, 2, 3, 4, 5, 6. Okay, and then here is the sigma bond formed between the sp3d hybridized orbital of I dengan 3p orbital of chlorine. So this one is also a sigma bond. So label the sigma bond here. Okay, one single thing you don't forget, the charge. You must not forget this. So here, but minus. Okay. So we got here lone pair. Tak boleh label tak apa. So this is how you draw the orbital overlap for your hybridization. Okay, remember how you want to draw, what shape you want to draw for the orbital overlap. You look at the electron group arrangement. Electron group arrangement, trigonal bipyramidal. It counts all the electron groups because we want to put the, what we call this, lone pair as well dalam lukisan. So we need to draw according to the electron group arrangement. Okay, but according to molecular geometry, it is in linear shape dah. Alright, so now we need to explain, okay? We need to explain it down there. So, okay, so to explain, so we need to explain the how does the form the bond form. So, one, the ICl sigma bonds are formed by the end-to-end overlapping between 3p orbital of Cl atom and sp3d hybridized orbitals of I minus ion. Okay, this is the first explanation. Second, according to Vesper theory, the molecular geometry of ICl2 minus is linear with bond angle of 180 degrees. So this is how you explain the question. Okay, so remember. Alright, remember. Okay. Alright, so now we move on to next question. ICl form plus. Okay, tadi minus, ini plus, tadi positif. Negatif ion, ini positif ion. So, the molecule is ICl4+. So, if you draw it Lewis structure, it will become like this. So this is how you draw the Lewis structure for this molecule. So you look at how many around the central atom, how many bonding pair? 1, 2, 3, 4. and one lone pair. So according to electron group arrangement, it is trigonal by pyramidal. However, according to the molecular geometry, it is a seesaw shape. So if we know the electronic configuration for I is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 5p5. Okay, so for electronic configuration for the normal I atom is 5s2, 5p5. Okay, however, for the positive ion, it remove one electron, so it will be like 5s2, 5p4. Okay, so now we can explain the hybridization process using the orbital diagram. So at ground state, so this is at ground state, S 5p. At ground state 5p4. It got 2 unpaired electrons. Okay, you look at the Lewis structure. It needs 4 unpaired electrons to form. It needs 4 unpaired electrons to form 4 sigma covalent bond. So we just have 2. So what we need to do, we need to expand the 5d orbital. We need to excite 1 electron from 5p to the empty 5d orbital. So at excited state, I plus 5s. 1, 2, 3, 4, 5. 5s, 5p, 5. So 1, 2. Okay, 1 here will excite to 5d, right? So 1, 2, 3, 4. So now 1, 2, 3, 4, 5, 1 5s plus 3 5p plus 1 5d will form sp3d orbital, 5 sp3d orbital. So at hybridized state, sp3d hybridized will form 1, 2, 3, 4, 5, 1, 2, 3, 4 sp3d hybridized orbitals, empty 5d orbitals. Okay, so now draw one lone pair because we got one lone pair according to the structure, and then 4 unpaired to form a sigma bond with the chlorine. Okay, so now we want to draw. So when we want to draw the hybridization of the central atom, we use the electron group arrangement because we want to include all of the electron groups, not just the bonding pair electron. So we use the electron group arrangement as the macam benchmark to draw the hybridization around central atom. So trigonal planar, trigonal bipyramidal. So 1, 2, 3, 4, 5. So this is the I. Okay, then you need to label sp3d, 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 sp3d. Okay, so now for Cl is 3p, 3p orbital. So 1, 2, 3. Sorry buru korang lagi lawa-lawa, okay? You guys need to draw it nicely. I cannot. Okay, so we got 4 Cl here and then 1 lone pair here, right? Okay, but then what? That one. Wait. course, we need to label first Cl, Cl, and then we need to label 3p, 3p, 3p. Alright, then we need to label the sigma bond form. Sigma, 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 sigma. And we got one lone pair here, like this. And also please don't forget your charge. The positively charged around the molecule is positive. So here is how you answer this question. Okay, so now let's do the explanation thing. So for the explanation, you can see that according to Vesper theory, the ICL, Vesper theory ni apa benda cikgu kau ni? Sorry, the ICL sigma bond are formed by the n-to-n orbital overlapping between 3p orbital of Cl atom and sp3 hybridized orbital of I plus ion. Okay, number 2 barulah according. Okay, according to Vesper theory, the molecular geometry is seesaw with bond angle of less than 90 degree, less than 120 degree. Okay, so this is how you answer this question. Okay, so for the question yang Miss tak sempat bincang, for example, question number 4A and B, question number 4A and C, and question number 5A and B, I want you to do it by yourself. Okay, because it's just a simple one. I already explained you the hardest question inside the tutorial book. And of course, I will give you more and more exercise on this question so that you can answer this type of question easily during the PSBM later on. Okay, this is a must. Okay, this question is quite is giving you a lot of marks, so I don't want you to lose any marks easily, because you can get mark easily, you can lose mark easily as well, because like for this when you just draw this like really complete, you can get like I think around 5 marks here only, 4 to 5 marks on here only, and during the explanation you get around 2 to 3 marks. This one got 1 mark, 1 mark, 1 mark, so you have to do it really careful. Okay, I don't want you to lose any of these marks. Okay, because it's really precious lah, sebab kalau tak nanti markah hilang senang, markah senang hilang. I don't want that to happen to you guys. Okay, so this is how you draw this is how you explain, this is how you describe the hybridization process. I will download this and attach this in your Microsoft Teams as well as your Telegram group. So don't worry, and I will upload this in YouTube lah, this video. Alright, okay. I think that's all for today. Yeah, I'm sorry for uploading this video late. So for tomorrow tutorial, maybe we will do more questions on hybridization, maybe. Okay, so yeah, I think that's all for today. We will stop this here. Thank you and Assalamualaikum. Bye bye.